What's going on, guys? So in this video, we are going to do a deep dive into Python modules and packages. We're going to take a look at how we can import modules, and we're going to take a look at how we can structure our code so that when the number of modules grows to a very large amount, we can structure our code using packages. And last but not least, we're finally going to figure out what in the God's name this means. So I've created a simple GitHub repo, and I'll make sure to post the link in the description below. But what I've done for this video is I've structured it out by creating 9 short lessons. And each one of these lessons is probably not going to take more than 2 minutes, but they each are going to cover a different aspect about Python modules or packages. And so I think just having it structured is going to make it a little bit easier from a learning perspective. So go ahead and pull this, clone this repo if you guys want to follow along. But like I said, these are very simple examples, so you probably don't even need to code along. It's just there to give you guys a brief overview regarding Python modules and packages. So let's go ahead and get started. All right, guys, let's go ahead and get started on lesson 1. So if you haven't already done so, clone this repo and then just expand lesson 1. And you'll see that we have 2 files. We've got the main.py file, this is our main script file. So this is what we're going to actually run. And then we've got a helper.py file. So this is a module that I've created ahead of time for us. And so let's just go ahead and click on this and let's take a look at it. So within this module, I've got 4 functions. And these are the 4 most useless functions, but they're just there for demonstration purposes. They could have been functions that do anything. Actually, they didn't even have to be functions. They could be objects. They could be dictionaries. They can be any variables. It doesn't really matter. I just chose 5 functions in this case. And so I've got, an add function, which just takes 2 numbers and then returns the sum. Obviously, you would never create this function. You can do this in any programming language without having to create a function. But once again, it's just for demonstration purposes. And then I've got, 1 for subtract, 1 for multiply, and 1 for divide. So basically all the core mathematical operations. And so I guess first things first, let's start off by defining what a module is. So in Python, a module is nothing more than a Python file. So if you have a Python file, that is already a module in itself, right? And so don't confuse it for anything else. It's not complicated. Any Python file is technically a module. All right, so what I want to do in lesson 1 is, let's say I'm working on my script, and I now want to use one of the helper functions that I've defined in my helper module. How exactly do I run them? So let's say I want to run the add function. What do I do? Well, let's try to just do x equals and then just call the add function directly in our main.py file. So I'm going to pass 2, 3. So we're going to add the number 2 and the number 3. It should result in 5. And then let's just print out x. And let's see what happens. And if you're following along, make sure you navigate into the lesson 1 directory. I'm already in there. I did that ahead of time. And we'll just run Python and then main.py. And what we can see is we get an error. It says name add is not defined, right? So it's not defined here. That makes sense. We don't see it defined here. It's actually defined in our helper module. So if it's defined in another file or in another module, how exactly do we import it? Well, very simple. What we do is we run import and then the name of the module. So in this case, the module name is helper. So I just type in helper. And notice I don't do .py. You just do the name of the module. You don't need the extension of the file. And so what Python is going to do is it's going to look for a file named helper in the same exact directory as our main.py file, because that's where we're placing this statement in. So we see when we run this command, it's going to see that there is a helper file in the same exact directory, and then it's going to import all of the objects from that module. So I'm going to hit save, and then I'm going to run it again, and I want to see what happens now. So when I run it again, we can see that we get the same exact error. It says name add is not defined. Well, what exactly happened? We imported this module. Why can't we access the add function, right? It's there and we're importing it. Well, here's the thing. When you do import and then a module, what happens is it creates a separate namespace for all of the objects and functions and anything else that's in this helper module. And so we can't access add or subtract or multiply or divide directly in the global namespace. We have to use the namespace that was created for this module. And so how do we do that? It's very simple. All we have to do is, instead of just calling add directly, we have to do the name of the module, which once again is helper, and we do helper, and then we do dot. And so now when you do dot, VS Code is going to automatically show you all of the different functions and methods that we have within the module. And so now we have access to add, divide, multiply, and subtract. So I'm going to call add. We'll call 2, comma 3 once again. Give that a save, and we'll run that. And look at that. It prints this out. So we have successfully imported a module into our main.py file. So we just saw how we can import one of our own custom-made modules. And I think it's important that we just quickly touch on Python's built-in modules, because a Python built-in module is not fundamentally any different than one of our modules. The only difference is we didn't create it, and it comes shipped with Python when you install it. And so I'm sure at some point, if you guys have been already playing with Python for a little bit, you're already familiar with Python's built-in modules and how to kind of work with them. But now hopefully you get an idea as to what exactly is happening. So as an example, let's just quickly take a look at how we would import a built-in module and show you that it's not fundamentally different than one of your own custom-made modules. So this is the Python time module. It's just used for working with time. And so what we're going to do is we're going to import it. And so to import the time module, we just do the same exact thing that we did with the helper module. So we do import, and then we do the name of the module. So it's going to be time. And so like I said, when you do import like this, we don't get access to any of the methods within time. So if you actually take a look at the documentation, there's a couple of different methods or functions. We're going to use, let's see, where's this time? We're going to do time.time. And so like I said, we can't just do time and then just call that, right? That's not going to work. If I hit save and then try to run that, it's going to give me an error, right? So what we have to do is we have to call time, which is the name of the module, and then we do dot, and then we get access to all of the objects within that module. So here we can now call time, and then I'll just print this out. And so now when I run that, you can see it prints out something with regards to time, right? And so I just wanted to show you guys that working with the built-in modules is going to be exactly the same as it is with your custom modules. There's no difference. So if you already mastered how to work with built-in modules, then you probably don't even need to watch this video. You probably already understand most of the things that you need when it comes to working with modules. However, I will show you guys a few extra tips and tricks and a few other things to give you a little bit of a better understanding. So maybe you guys want to stay tuned, but if you just want to know how to import things and do some basic things, and you already know how to do that with the built-in modules, you guys are good to go. You can just watch the next video. All right, guys, so let's move on to lesson 2 now. So if you take a look at the lesson 2 directory, we've got 2 files once again. So we've got our main.py file. Once again, it's the same exact script file that we're going to use to write our code. And it's empty now. And then we've got our helper module. And our helper module is the same exact one as the lesson 1, except I've created 2 extra functions. So I've got one called my name, which just prints out the word hello. Once again, another useless function. And then I've got another function called _test, and that prints out the word hello as well. I may probably change this to test or something. Doesn't really matter. And so let's take a look at our main.py file. And what I want to do in this video is I want to show you guys how to import objects or functions from a module in a slightly different way. Because if we take a look at lesson 1, we saw that we can import the module by calling the name of the module. And then what we can do is first of all, it gets its own namespace. We have to do the name of the module, and then we call the individual functions or objects that are associated with that module. That's one way of doing it. However, there's another way of doing it. What we can also do is we can say from, and then we do the name of the module. So once again, we're going to call the name of the module, and I'm going to do a helper, and it's going to, by default, look for a file named helper.py in the same exact directory that I'm calling it from. And then we can say import. And then now we specify an individual function, an individual object or class or anything that we want to import from the helper module. So if I'm only ever going to use the add function, why should I bother importing all of these guys? What I can do is I can just do import and then call the add function. And so now if I do x equals, I don't need to do helper.add. I can just do add. Because when you do this kind of import statement with this syntax, it imports this into our global namespace. We no longer have a private namespace for these functions. So I can do add, and then we can call 3, 3. And then we'll just print this out just to verify that the function works. We run that, and we can see that it was successful. And so now you guys know how to import individual functions from a module. And here's the thing, right? If you wanted to import a couple of different functions from this module, you can just do comma and then name the other function. So if I wanted subtract, I now have access to subtract. And maybe I also want divide. And so then I can do y equals subtract, and then we can subtract 9 and 6. Whoops. If we run that, we can see that both of the functions worked properly. Now, let's say that you wanted to import everything from the helper module, right? We could once again just do import and then helper, that's going to import everything. However, that creates its own its own private namespace. But what if you wanted to kind of do this type of syntax so that you can import these functions into the global namespace, so that you can call the functions directly without having to do helper.add? Is there a way to import all the functions without having to write them out one by one by one? Absolutely. What we can do is we can say star. So what this means is that we're saying that from this helper module, I want to import everything. And so now, if I run this again, it should still work. And it did. And if I wanted to, I can change this to divide and run that. We can see that worked. And then what's the other one? Multiply. And so now we have access to that. However, there's a couple of gotchas with this. First of all, it's almost never recommended to do this. I just wanted to show you guys this just for the sake of completeness, just in case you might see this one day. And I wanted to make sure you guys understood what it is, but it's bad practice just because, I mean, this is a very small module, but there could be hundreds of functions. And when you do that, you're importing all of them into here. And then when you run them in your code, if you take a look at this, right, we have this add function, but imagine we're importing all of the functions from, 5 or 6 different modules, not just one, right? We have no idea where this add function is coming from, right? Because we did this kind of import statement. At least if we wrote add, we know exactly what module it's coming from because it's listed right here. And we know that if we do import helper, well, then we have to call it by doing helper.add. So we automatically know what module it comes from. So it's generally bad practice to do this kind of, I forget what this is called, like a wildcard syntax to import everything. So just a little bit of an FYI. And one other thing to note is that when you do this syntax and you try to import everything, it actually doesn't import all of your functions. It'll import everything that doesn't start with an underscore. So just to prove that to you guys, I'm going to just delete all of this and we'll just run underscore test. And so now if I do Python main.py, right, it says that underscore test is not defined. And just to make sure that everything else still works, if I run, multiply 2 and 3 and just print that out. And we run this now. We can see that the 6 printed out properly. So it looks like it's still importing everything else. It's just this underscore test doesn't work. And that's because, once again, it's got the underscore. So just remember, when you have this syntax, it's going to import everything except for whatever comes with, whatever starts out with an underscore. All right, guys. So let's move on to lesson 3. Now, lesson 3 is going to be a little bit different. We've once again got our main.py file, but now we have 2 separate modules. So we've added a little bit of a wrinkle to our scenario. And so in module 1, we've got a function called test. And this function just prints out running test from mod 1. Now module 2, very similar. It's got a function called test as well. And then this just prints out running tests from mod 2. So mod 1 has a function named test. Mod 2 has a function named test. They just print out slightly different things. And I think you know exactly where I'm going with this. Now, if we wanted to import, these modules, we can do the standard import mod 1. And then if we wanted to, we could also do import mod 2. So if you wanted to import both of those functions, you can also put it on one line. So if we want to do comma and then mod 2, that should be fine as well. However, my auto formatter, if I hit save, it's going to just move it into a separate line. But keep it in mind, you can do the comma and then add multiple imports on one line. And so if I import it like this, remember each one gets their own namespace. And so then I can run mod1.test, and then I can also run mod2.test. And everything should 100% be fine. So if I do Python main.py, everything works just fine. We can see running test for mod1, running test for mod2. So far, we already know this, haven't learned anything new. Now, let's say that I want to do import. Actually, I want to do from module1, I want to import the test function into the global namespace. So now I can call test directly. So let's save that. I'm going to run this, and we can see that running test from mod1. Now, what happens if I import the same test function from module 2? Right? Because module 2 also has a function, and it's named exactly the same name as test, which is the same name in module 1. So now if I do from mod2 import test, let's see what happens. And then now I'm going to run test. What do you think is going to happen? We're importing the same, we're importing a test function from two different modules. So what's going to happen? Well, let's take a look. I'm going to run Python, and we can see that running test from module 2. So it looks like whatever was the last import statement is what got used. And so really the problem is that I'm trying to demonstrate is, in this case, we've got a little bit of a name clash because we're importing the test function from module 1 into the global namespace, and then we're importing the test function from module 2 into the global namespace. So they both share the same name, so whichever one comes second is going to take precedence. But in this case, what exactly do we do, right? This is a possible situation that you could end up in with two different modules with the same exact function name. How do you actually import both of them into the global namespace? Well, one of the things that we can do is we can import it with an alternate name. So what I can do is I can say from module 1 import test as, and then we give it an alternate name. So I'm going to call this mod1_test. And so it's going to import this test function into the global namespace, but it's going to rename it as module1_test. And I'm going to do the same thing with module 2, although in this case, I don't have to change module 2 because we no longer have a clash. But just to show you guys, I can rename this as module2_test. And so now you can see that it's throwing an error because there's nothing in our global namespace called test. So I'm going to remove that, and I'm going to run mod1test. And I'm going to run mod2_test as well. And let's see if the renaming works. And it looks like it did. So it printed out both of them just fine. And this alternate name that you can give a function, you can do the same thing when you import it using the other format. So if I do import, in this case, mod1, right? So instead of doing from mod1 import something, and I'm just going to import the entire module, I can rename the module. And I can say import it as my mod. And so now all of the functions in that module are going to be accessible through the my mod namespace. So I can do my mod dot, and then we've got the test function that we've always been running. Let's run that, and it looks like it works just fine. Now with Python, we do get the flexibility of doing conditional imports. So we could have an if statement that has some sort of condition, and only if that condition's true, we then import a module. Or if we have a function, we can actually import a module within the function so that it only runs when that function is called. So as an example, let's say that we, let's just create a variable called x, and we'll just store a value of 10. And we could say if x is greater than 5, we do something. And in this case, we can actually import my helper module. And then from here, I can do print, and then we'll just call helper.add, and then we'll add x, and then, I don't know, the number 2. So if x is greater than 5, which it is, then we will import this, and then we'll print out the that number added with the number 2. And so then if I run Python main.py, you can see that it did successfully import it within this if statement. So this is an example of a conditional import where we only import it if a certain condition matches. And on top of that, we can also import within a function. So if I create a function called, let's say, calculator. We can say within this function that we're going to import helper. And then we can do, we'll do print once again, and then helper.add 3 plus 2. And then we'll just call our calculator function so that it actually does get imported and run. And so now if we run this, we can see that it did successfully work. So this was just a short lesson. I just wanted to highlight that we can do conditional imports within Python. All right, moving on to lesson 5. Go ahead and open up this folder. And once again, you're going to see pretty much the same 2 files that we always have. We've got our helper module, and then we've got our main.py file. And in this lesson, what I want to do is I want to go over a special function called dir. And you guys may have already seen this before. But what I'm going to do is I'm just going to do a print. And then we'll do print dir so we can see what the output of that function is. And so if I run Python main py, you can see that we get a couple of random things. And so this all this function does is it's going to return a list of names within our current namespace. So in our global namespace, what is everything that we have access to? And so these are just the default ones. And what I want to do is I want to show you what this looks like before and after we import our own custom module. So if I go below this and I do import, and then we'll import our helper module, but we're going to use this syntax. So remember, when we do an import and then just call the name of the module, this is going to create its own custom namespace. And so then if I do a print and then dir again, so that we can see all of the names in our current namespace, it looks like unfortunately my auto formatter, which I don't know how to turn off, is going to move it all the way to the top. So I'm going to just remove this, and then we know what the output looked like before. So we can see what we have available. And if we run this now, we can see that we have all of the same exact ones as we did before, but then we also have helper. So helper got added to our namespace when we imported it. And so that's why we can do helper and then call whatever method we want, because we imported it. Now, if I change this to a different style of import, if I do the from helper import, and then we'll pick one of our functions. If I run this now, guess what's going to happen? Well, first of all, we lost helper because remember, when we do this kind of import, it's going to import just this function into the global namespace. And so now in our global namespace, we now have the add function. And then if I add subtract, guess what's going to happen? I think you guys already know. We can see that we now have add and subtract. And if I import everything, once again, I'm sure you guys can figure out what's going to happen. We can see that it imported add, divide, multiply, and subtract. So it imported all of them. And so that's all I wanted to show you guys, is that, this function is just going to show you what you have access to in your current namespace. And so hopefully this gives you a little bit of better idea as to how these imports actually work and what exactly they're doing for you. All right, so moving on to lesson 6, once again, we've got our main.py file and our helper.py file. And, I mentioned earlier that any Python file is a module. And more importantly, what I want to state is that a module can also act as its own Python script. So modules aren't just there so that you can import certain functions into your main.py file. I can run my own code in here. So if I wanted to run, print, and then I'll just say, hey, this is my helper module. Well, I don't need to import any of this into my main.py file. I can run this module as a script on its own. That's a feature of Python. So I can do Python helper.py. And so now you can see that it says, hey, this is my helper module because I ran this as a script. And remember, this is just a Python file. Really, there's nothing different between my helper file and my main file. They're all just individual scripts. And the reason why I wanted to highlight this is that, once you put your own custom logic into your module, which is 100% acceptable because, in a bigger application, you might have a module that has some functions that you import into your main file or any other files, but you may have some custom logic in here for certain instances when you run it as its own custom script. Perfectly acceptable thing to do. However, because we have this print statement here, I want you to take a look at what happens when I run main.py. So in my main.py file, I'm just going to say, we'll just say x equals 5. And then we're going to run Python main.py. Okay? Nothing prints out because my main.py file is not printing anything out. But watch what happens when I do an import of my helper module. Something interesting is going to happen. Look at that. It says, hey, this is my helper module. So it looks like when I ran this import statement, it ran this code. So really, when you're importing a module, it's actually running through your code and running it. And this is a little bit of an issue because in my main script, I don't want this cluttering up my main script. I just want to import, maybe an add function or a multiply function or one of these functions or all of them. But I don't want to run the custom code that's within the module. I just want to import those functions. So what exactly do we do now? Because now this, all of this custom code is now ruining my main.py file. Is there any way I could somehow put in some logic to say that, when my module is run as a script, right? And when I say run as a script, I mean they call Python and then the name of the file. Well, then I want to run all of my code. But when it's imported into my main.py file, right? When I call Python main.py and then we have an import statement to import it, I don't want it to run all of my custom code. I just want to be able to import these functions. And there is a built-in way to do this in Python. And so when any module or Python file is imported as a module, a special dunder variable is set. And so the dunder variable is, and I'm sure you guys have seen this already, but it's __ name __. So this variable gets set to a specific value. And so when a file is, when a module is imported into another file, this variable is going to be set to the name of the module itself. So __ name is going to be set to helper. And I'm going to just comment this out so there's no errors. However, if I run Python, I didn't mean to delete that. But if I run my module or my file as a script, so if I call Python helper.py, then what's going to happen is that the the dunder variable, or the dunder variable is going to be set to __ main. And so this is just for your reference, so we can prove this. So I'm just going to do print __ name. And so first things first, I'm going to run my module as a script. So if I do Python helper.py, and I think I forgot to save. Right, and so you could see that it printed this out and it got set to main. So this just confirms what I said. When we run this as a script, it's going to set this special dunder variable to be __ main __. Now, when we import it into another script and then run it, let's see what happens. Interesting, right? It gets set to the name of the module itself. So knowing this, we can actually implement a simple if statement to say, hey, listen, if this dunder variable is set to main, that means this is being run as a script. So I do want to run that code. However, if this dunder variable is set to the name of the module, that means it's being imported, so don't run my code. So how do we do that? Very simple. Let's get this if statement going. I'm going to say if, and we'll say __ name __ equals, and then __ main. Right, so what happens if this dunder variable is set to main? That means this file was run as a script. So then we want to run all of our code. So here I'm just going to say run all my code. And so in this case, it's just going to be a print statement. And I'm just going to copy this print statement from here and paste it down here. And that's all you have to do. So whatever code you want to run, you just paste it into this if statement, and it's going to run only when we do Python and then helper.py, only when we run this as a script. However, when it gets imported, this will never run because the dunder variable will not be set to __ main. It's actually going to get set to helper. So let's test this out. So if I do Python helper.py, we can see that it did successfully run that print statement. So far, so good. And then if I do Python main.py, nothing gets printed out. So perfect. We have now successfully implemented that logic, and I'm sure you guys have seen this before, but you now finally understand what this is and why we need it and why you see it in a lot of people's code. So as you start building more complex applications, you're going to start creating more and more modules. And you're going to find that you want a way to organize and structure all of your modules. And the way we do that within Python is by using something called packages. So packages are a way to group modules together. And packages are really just a fancy way of saying folders, right? We have folders, we have directories. This is something that's built into any operating system. So we already kind of understand what folders do, what directories do, right? Because we have a downloads folder on our machine, which stores all of the files we've downloaded. We've got My Documents, which stores all of our documents. We've got an image. We've got a folder for movies, which is going to store all of our movies. Your code is not fundamentally any different. And so, as an example, if you take a look at lesson 7, I've actually wrote out a couple of different modules, and I wanted to group them together. So what I actually did was I created a package, which once again is nothing more than a directory. All right. And so I created a package called database, which is going to store all of the modules associated with interacting with databases. Right. And so I've got one called mod1, mod2, very unoriginal names. And then I've got a module for all of my utility functions called utils. And once again, I've got one called mod1 and mod2. And what's nice is that, because these are in separate modules, since these modules are in separate packages, we can name them the same thing. It's okay. They're not going to step on each other's toes. So once again, just to highlight, package is nothing more than a directory that's used to group similar modules together. Now, one thing to note. So starting in before version, I think Python 3.3, to actually create a package, it wasn't as simple as just creating a folder. You had to do one extra thing. You actually had to go under each package or directory, and you had to create a file called __init, and then __.py. Now, this isn't needed any longer, so we don't need to do that starting version 3.3, I believe. You may want to double check the exact version, but if you're on a fairly recent version, you don't actually need to do that. So that's just something to keep in mind. So if you're looking at some older code, you may notice this file. Just keep in mind that it's not going to break anything if you're running a new version. In fact, I would recommend just go ahead and just adding it to all your folders. It's not going to break anything. And it doesn't really do anything in the later version. So we could delete that for now. Now that we have all of our modules, organized in nice packages, how exactly do we import these? It's very simple. So in our main.py, let's say that if we go to module 1 under database, we've got a function called connect, which is kind of representing a function used to connect to a database. And in this case, all it does is just print connecting to database. So how do we import this function into our main.py file? Well, to import a module, we have two different syntaxes. Let's start off with the import syntax. So we could do import, and we want to import mod1. So normally we would do mod1, right? But there's no mod, but if we do it, if we just write mod1, it's going to look for a module in the same exact directory as our main.py file, which is under this lesson directory. And there's no mod1 file in the same directory. The mod1 is within our database directory. So to actually access that, what you have to do is you have to append the name of the package. So the package is called database. So I do database, and then I do dot. So to actually get a module from this database package, you do dot, and then the module name. So I can do mod1. And so now if I want to call that connect function, I can do database.mod1, right? Because that's the namespace. That's the name of that, namespace. And then from here, I can then do dot connect. So then if I do Python main.py, we can see it says connected to database. So we have successfully imported that connect function. And then if we wanted to import, this disconnect method, this disconnect function from mod2 within our database package, we do the same exact thing. We can do import database.mod2, and then we can say database.mod2.disconnect. And so now if we run this, we can see connecting to database and then disconnecting to a database. So importing, very simple. You just have to append the package name and then do dot. And if we're a couple of directories deep, so like if there's a package within this database package, you just do the name of the second package. I'll just say second package and then do dot and then the name of the module that you want. So you just keep adding dots and then the name of the package. Very simple. And just for completeness, I'm going to then also import mod1, mod2 from the utils package. So here I got a function called encrypt data, and then I've got a function in mod2 called decrypt data. So let's just import that for completeness. And remember, we just do the name of the package and then the name of the file. And I'll import the other one as well. So then we can do utils.mod1.encrypt data, and then mod2.decrypt data. And then when we run that, we can see all 4 print statements. Now let's remove that. And, like I showed in the earlier section, we do have the import syntax, but we can also do the from import as well when it comes to modules that are grouped into packages. So let's say I want to import from database within module 1 just the connect function. Now there's only one function in here, but in reality there would be more than one. So we can we can type in from, and then we do, it's pretty much the same concept. We'll do the name of the package, and then we do dot, and then we grab the name of the module, and we say import, and then what was it? Connect. So we'll do it connect. And so now we can just, and with this syntax, it doesn't matter if it's in a package, it's going to import this into our global namespace, just like it did before, so we can call connect directly. Now, if I run this, we can see connecting to database. Now, if you want to import this with an alternate name so that you don't clutter up your global namespace, I can call this, we could say as, and then we can rename it to something. So we can call this my connection or something, mycon, and then we can run mycon. So in reality, everything that we've learned so far is still valid when it comes to packages. You just have to append the package name. So now if I run this, once again, still works. And on top of that, if you wanted to, we can also rename that module. So if I did the same old import database.mod1, we can import that as a different name. So we'll call this datacon. And so then I can reference datacon dot and then call the connect function. So save that, we'll run that, and once again, it still works just fine. So that's how you work with packages. Not very difficult. It's really just folders and nothing more. All right, guys, so moving on to lesson 8. You're going to see that in lesson 8, the project structure is going to be pretty much the same to lesson 7. I've got my main.py file. I also added the helper module as well, but I've got the same 2 packages that I had created before. So I've got the database package and I've got the utils package. And then within each one of these packages, I've got a module called mod1 and mod2. And that's for both the database package and the utils package. And so the one thing I want to talk about in this section is that in the last section, I mentioned that prior to version 3.3, to actually make a folder be a package, right? To actually be considered a package, we had to create a new file within that within that directory, and call it __init _py. So this __init __.py file under the database folder would have turned this into a package that we can use in our code. And starting in version 3.3, once again, double check what version if that's the correct version, we no longer needed this file. However, this file does actually modify the behavior of how our code actually works just a little bit. Because anytime this package or any module within this package get imported, into our main.py file, what's going to happen is Python's going to look for this __init __.py file. And if it does exist, it's going to run the code in this file. If it doesn't exist, no biggie, it just skips over. But if it does exist, it's going to run that code. And to prove that to you, if I open up this file and I just do print, hey, my code ran, we save this. And then in my main.py file, I'm just going to either import one of these modules or a specific function from the module. So I'm just going to say import database.mod1. Now notice in my main.py file, there's no print statements or anything like that. So if we run my main.py file, you can see it says, hey, my code ran. So this confirms that when we import a package or a module from a package, if it's got an init.py file, it's going to run whatever code is in there. And so this can be used to basically execute any package initialization code. So if you need something specifically run anytime a package gets imported, then you can put that code in here. Now, the reason I wanted to show you guys this is that let's go back to our main.py file, and I'm going to change this up. I'm going to say from, and then we'll say database.mod1. Or actually, I'll just say from database, import star. What do you think is going to happen? Right? I think most of us are naturally going to assume that if I do from database, which is not a module, it's actually my package name, and I do import star, it should ideally import both or all the modules within the package. So let's actually take a look at this and see what happens. And I'm actually going to do a print dir. Right, so this is going to actually print out everything in our current namespace. And so if I run python main.py, let's see. So we've got all of the default built-ins, but I don't see anything referencing module 1 or module 2 or any of the functions in there. So this didn't look like it did anything. And so this is actually expected behavior. So when you try to import everything from a package, it's not going to import anything. It's not going to import the modules automatically. There's no convenient way to do that. However, what we can do is we can go under this init__.py file, which is our initialization file. So anytime we import this package or any modules from this package, this is going to run. And what we can do is I can create a variable called __all__. And then here we set this equal to a list. And in this list, we can specify all of the modules that we want automatically imported when we do from database import star. So if I put in mod1, and then I'll also put in mod2, now if I run this, you can see that in our namespace, we have now successfully imported mod1 and mod2. So I can access mod1.connect. And it works now. And look at that. So we can use this initialization file to make it so that we can import all of our modules automatically. Now, like I said, this is generally not recommended, but I did want to show you this just for the sake of completeness. And on top of that, we can also do this for individual modules as well. So if we go to our main.py file, I've got this helper module. It's not really in a package, but it doesn't matter if it's in a package or not. The same rules are going to apply. If I do import, when I do from main import, from helper import and star, remember it's going to import everything from this module. So it's got, these are the same 4 functions that I've always had. And then if I do a print dir, we can confirm that it imports add, divide, multiply, and subtract. Perfect. Now, let's say that maybe some of these functions I don't want to automatically get imported when I do that. How do I make it so that they don't automatically get imported? Well, we can kind of use this initialization technique where we have this __all variable. And so what I can do is I'm just going to copy this and go under the helper module, paste it in here, and then I'm just going to specify just the methods that I think should be exported from this module. So maybe I only want to allow them to import add and subtract. And so now if I go to my main.py file and run the same thing, we only get add and subtract now. So we don't get multiply and divide because of this config right here. Keep in mind, I can still manually import multiply. That's not going to break anything. Right? And so now we have access to multiply. It's just when you do the star, when you do the asterisk right here to import everything, you can just make it a simple way to just kind of trim down what actually gets imported. And going back to, the one under the package, right? This is just going to tell you which modules will get imported. In this case, we're going to say, hey, both of these modules will be allowed to get imported. If we just trim this down to just module 1 and then change this, we can then do from database import star. And so now only module 1 should get imported. Hopefully that made sense. I think I kind of bounced around a little bit, but I don't think this lesson was too helpful for you guys. You don't need to worry too much about this, but this is just more of a FYI. This is what you can do with that initialization file. All right, guys. So we're down to our final lesson, which is lesson 9. And so the topic of this lesson is going to be subpackages. And so let's open up the lesson 9 directory. And so keep in mind for this project of this lesson, the root directory for this project should be lesson 9, right? So you ignore everything else. Just think of this as the parent directory where all your project code is going to be stored. And within here, we've got our main.py file, and then we've got our package called utils. Once again, a package is nothing more than a folder or a directory. And then when I open this, you'll see that we've got 2 more folders. So we haven't seen this. We haven't seen a package within another package, but this is what's referred to as a subpackage. So it's just a directory within another directory. So the utils package has 2 subpackages called subpackage 1, subpackage 2, very unoriginal names. And if I open those up, you'll see that package 1 has a mod 1 module and a mod 2 module, and package 2 has a mod 3 module and a mod 4 module. And each one of these modules just has one function. So module 1 has a function called func1, module 2 has a function called func2, module 3 has a function called func3, and module 4 has a function called func4. So let's say that in our main.py file, we want to import, let's say mod 1, right? What we can do is, just like what we did before, that shouldn't be there. We'll start from scratch. We can do import. And then we do import, and then we have to do utils, which is the name of the package. And then within package, let's say we want to import mod 1, then we have to go into the subpackage. So we do dot subpackage, and then we do dot module 1. And so from here, we can then call utils dot subpackage 1 dot mod 1 dot func 1. And that should successfully import it. So we'll try that out, and it should say, don't worry about that func3 yet. That's just due to something else. Here, let me save this and then rerun this. So I just forgot to hit save. So yep, now it says func1. So that's doing exactly what we expect it to do because it's importing this func1 function, and then it's going to print out that one statement func1. And we can use the other kind of import statement as well. We can say from, and then we can call utils.subpackage1.mod1 import, and then we can call func1. So now we import func1 into the global namespace, so we can just call func1 directly. We run this again. We can see that it works perfect. Now I'm going to throw a little bit of a twist now. Let's say that we're in module 1, and I want to import something in module 2, right? This is something we haven't done. We haven't imported one module into another module. We've always imported into our main.py file. So how do we do that? Well, it's not fundamentally different. There's really 2 different ways about going about this. Right? We have what's referred to as an absolute import, and then we have what's referred to as a relative import. So an absolute import means that we're going to give the full path to the module. So let's say we do from, and then what we normally do if we're in the main.py is we do from, we do utils, and then dot subpackage 1, and then grab module 2. Now, for module 1, if we're importing it from there, if we're going to do an absolute import, it's going to be the same exact thing. So from the root of our project, from lesson 9, how do we get to module 2? Well, if we're in the lesson 9 folder, which is kind of like where the main.py file is, we do the same exact thing. We go under utils, and then we do subpackage 1, and then we do mod 2. And then we can import func, wait a minute. Sorry, it should be import, and then we can call func2. And then at this point, we can also call func2 as well. Right, and so now you can see that this works just fine. And in this case, if I call func1, it should ideally import func2 and call that for us. Actually, yep, it should. So let's run that, and we can see that func1 ran and then func2 ran. So that's how a module imports another module. And that's using an absolute import. So that gives the full path from the root to the project directory, which in this case is lesson 9. So you go from the root, how do I get to mod 2? So you go into utils, then subpackage, then mod 2. However, we also have relative imports. And relative import is, what's the path to get to module 2 relative to where I am? So since I'm in mod 1, relative to me, how do I get to mod 2? Well, I'm in the same exact directory. So I can say from, and then I can say dot And then we can say from the current directory, go to mod2, import, and then we could say func2. So this dot means the current directory. So since module 2 is in the same directory as module 1, I could say go to the current directory, grab module 2, and then from there import func2. And let's try that out. Looks like it still works. Perfect. So this is an example of a relative import because I'm importing it relative to where I am within the code structure. So hopefully you guys understand the difference between absolute and relative. Absolute starts all the way at the top and has to work its way down to whatever module you're trying to import, whereas relative import is going to import it relatively to from where you are. And to give you a better example of how this works, instead of importing module 2 into module 1, let's import module 3. So that's going to be in a different subpackage. So we got to do a little bit more finessing. So let's remove func2. And let's figure out how to import a function from mod 3. So mod 3 has a function called func3. Let's import that. So here, let's start off with an absolute import because that's the easiest one. So we're going to do from, right? And then we have to do the absolute path. So starting from the root directory, how do we get to module 3? So let's minimize this for a second. So we go to utils, subpackage 2, then module 3. So we just do utils dot subpackage 2 dot mod 3 import func3. So now I should be able to call func3. And so now if I run this, we can see it runs func1 and func3. Perfect. That's an example of an absolute import. Now let's try a relative import. So we have to figure out where we are within the project structure. So module 1 is where we are, and we want to get to module 3. So we have to go up a directory. Then we have to go into subpackage 2 and then into module 3. So first things first, we know that dot grabs the current directory. How do we go up a directory? Well, you do 2 dots. 2 dots goes up a directory. So now we're at subpackage 1. We're at utils essentially. So we do dot dot, and then we call subpackage 2. And then we grab module 3. And then we import func3. So this is a relative import once again, because we're doing it relative to where module 1 is. So we have to go up a directory, then into package 2, then into mod 3, which is what we're doing right here. Save that, run that. Looks like it works. And so there you have it, guys. At this point, you guys should be absolute package and module experts when it comes to Python. Hopefully I cleared up a lot of confusion you guys might have had. And, if you have any questions still, feel free to leave a comment. And if you have any ideas for topics you want me to cover in the future, I believe this is my first Python video. You're normally the JavaScript guy. So if you want to do more Python videos, let me know in the comments section. I'm happy to add some more.